Our world is an incredible place, a place of beauty, wonderment, and even mystery. A mystery that goes back thousands of years, part of a never-ending search for the basic truths and principles of our existence. And through it all, people asked these same questions. What is the world made of? What are the smallest, most fundamental particles in all the objects we see? The ancient Greek philosophers and scientists debated these questions. They were the first to imagine the existence of the atom, an incredibly small particle that was part of every single thing, something so small you couldn't see it with the naked eye. Millions of atoms could exist on the tiniest objects. They also joined together into molecules that were the building blocks of all earthly matter. For centuries, scientists believed that the atom was the smallest particle. But in 1911, it all changed. A New Zealand-born scientist working in Britain, Ernest Rutherford, performed an historic experiment. He discovered that the atom was actually made of something smaller, a nucleus. And later, scientists found the electron, a particle that floats inside the atom away from the nucleus, a particle with a negative charge. Had we now found the smallest particle? No, not by a long shot. We soon learned that the nucleus has two smaller constituents, a proton and a neutron. As its name suggests, the neutron is neutral. It has no charge. The proton has a positive charge and balances off the negative electron. Until the 1960s, these were considered the most basic particles. But now we know better. There are actually even smaller particles, called quarks. In 1964, 3 quarks were suggested: the up, down, and strange. 2 up quarks plus 1 down equal a proton, and 2 downs plus 1 up equal a neutron. But those weren't the only quarks. In 1974, a 4th, called the charm, was discovered. In 1977, the bottom quark was found at Fermilab. And finally, in 1995, the 6th and final quark, the top, was observed at Fermi National Accelerator Laboratory in Batavia, Illinois. As of now, quarks are considered the most basic particles. But some physicists think that even these may be comprised of something smaller. As always, they keep looking and searching. Over the years, this type of search has led to other discoveries. For example, we now realize that every matter particle also has an antimatter particle. There are also particles called leptons. In fact, there are 3 different types of leptons: the electron, the muon, and the tau, all with negative charges. And the electron neutrino, muon neutrino, and tau neutrino, all neutrally charged. As you can see, there's a myriad of particles in every single object. But what do they look like? How do they behave? Typically, they're depicted as dots, circles, squares, or other familiar configurations. But it's not that simple. Leptons and quarks behave not just as particles, but also as waves. This dual nature is explained by quantum mechanics. What do we usually mean by the words particle and wave? When we say particle, we usually think of something like grains of sand, which in this example pass through the slits one by one. Waves are like water waves. The wave passes through both slits together, then forming a diffracted wave. Notice that the diffractive wave is tallest halfway between the 2 slits. We can compare this duality to electrons. Like a grain of sand, the electrons pass through the slits one at a time. But as many electrons accumulate, they pile up in a pattern like the water wave. Taken as a whole, the electron behaves like a wave. Are these tiny things particles or waves? They are both. It is called the dual nature of particles. But why are these particles so important? Why do we keep studying them? Because we need to understand the physical laws that govern the universe. It's simply the human value of understanding and exploring, of learning everything we can about the world we live in. This understanding and knowledge leads time and again to important breakthroughs, new developments in technology, medicine, and many other vital areas. This search for the truth leads to great and often unexpected benefits, to discoveries that change our world and ultimately uplift the human spirit.